about stream gradients, we also need to talk about something called Knick points. You and I know Knick points better as two other names, waterfalls or rapids. And where there's a waterfall or where there's a rapid is where there's an abrupt change in the gradient. It goes from a high elevation to a low elevation really, really quickly. And because it does so, it has what we call high hydrologic head, and it's able to do a great amount of work with that falling water. And that falling water creates an edge that's right here called a Knick point. And that Knick point then erodes material. In the case of waterfalls and rapids, if there's not a big change, then you're going to get rapids. If there is a large drop, then you're going to get a little bit of a waterfall or an enormous waterfall. And what's happening here is I've got really tough rock, cap rock right here. It's more resistant to erosion, but the material underneath is really susceptible to erosion. So when the water falls over this harder rock, it sort of comes in underneath and erodes this material, and it cantilevers the harder rock over the edge, and eventually it becomes a fulcrum and it can't support its own weight, and that harder material falls below, creating this riprap material down here. All right, so here's a waterfall that has a large distance. Here's rapids that have a shorter distance of drop with them. The Knick point is where that drop occurs. All right. So classic example are the Niagara Falls, which aren't too far from us. You can see that we have a change in elevation starting to occur before we get to the falls themselves, with a lot of rapids occurring, and then eventually we hit the Knick point. And this Knick point historically used to be out here somewhere, and over time the river, through erosion of the Knick point, migrates back up the river. So eventually the Niagara Falls are going to be out here somewhere, and enough time it'll be out towards the bridge. So all Knick points migrate upstream.